Two products can inflate in the same time and still finish with completely different firmness. Fast filling is mainly a volume and flow problem. Final shape and feel also depend on pressure, fabric geometry, air chambers, valves, leakage, and the load on the product. First, identify the air architecture. A sealed product fills, closes a valve and holds pressure. A constant air structure keeps the blower running to replace distributed leakage. An intermittent system stops at a target state and restarts for top-up. These modes create different motor, noise, thermal and control duties. For a first estimate, required fill flow is usable product volume divided by target fill time, plus expected leakage. But that is only the starting point. The product is compliant, air is compressible, and its back pressure changes as the walls lift and tension increases. Verify the full transient rather than one average number. The operating point moves during inflation. An empty product may accept high flow at low pressure. As cells take shape, the hose, valve, manifold, and fabric add resistance. Near final firmness, pressure rises and flow usually falls. The blower curve must meet the evolving system curve through the complete cycle. Think in 4 states: empty and high flow, shaping, firm at higher pressure, then hold or top up. A motor sized only for the first state can stall or overheat later. A unit sized only for the final pressure may fill too slowly, sound harsh or waste package space. Constant air products have a different steady state. Delivered flow must balance leakage across seams, vents and openings while maintaining the intended shape under load and wind. Leakage is part of the design, not automatically a defect. Test its distribution and worst credible condition. Small passages can consume surprising pressure margin. Inlet guards, impeller entry, outlet transitions, flexible hose, small valves, and manifold all matter. Check for kinks, collapsed hose and partially open valves. Free air fan data cannot prove installed inflation performance. Choose the air mover by the required flow pressure region and duty. Axial, centrifugal, regenerative and positive displacement architectures occupy different parts of that map. Compare them at the same supply, restriction, speed, temperature, sound boundary, and package size. The product name alone does not select the technology. Comfort and reliability share the same package. Blade and motor tones, valve hiss, structure-borne vibration, motor temperature, supply tolerance, mounting and duty cycle all affect the user experience. Measure sound as a spectrum and in the assembled product, not only as one bench number. Control the product state, not just motor speed. Pressure, current, temperature, timer, valve position and feedback can define fill, stop, hold, top up and fault states. The exact sensor set depends on risk and cost, but every commanded state needs a measurable acceptance condition. Test blocked inlet, kinked hose, large leak, overpressure, stall, hot restart and reverse flow. Define safe limits, alarm or shutdown behavior, pressure relief where required and retry rules. Validate voltage extremes, repeated cycles, high and low temperature, acoustic change in life. For an OEM review, send usable volume, fill time target, pressure range, leak allowance, hose and valve geometry, blower curve, supply and control, duty cycle, sound target, thermal limits, fault response and endurance conditions. Ordinary air mattresses are not safe sleep surfaces for infants. Follow product warnings and applicable safety requirements.